The next question is question number 4, derivative. Now we have to find derivative of 2x minus 3 over 2x plus 1. Solution: let f of x is equal to 2x minus 3 over 2x plus 1. Again, as we solved question number 3, this is again in the form of fx over g of x. So when we apply derivative on both sides, left side will become f prime of x, and applying derivative on right hand side, again by using quotient theorem, the denominator will become in the form of square. So 2x plus 1 whole square, 2x plus 1 will be as it is, and derivative will apply on numerator, which is 2x minus 3 minus, and then numerator will be as it is, derivative 2x minus 3, and derivative will apply on denominator, which is 2x plus 1. So 2x plus 1 will be as it is. When we apply derivative of this part 2x minus 3, using some theorem, derivative will apply on 2x and derivative will apply on 3, but 3 is the constant term, so the derivative will become 0. We have left only 2x, so derivative of x will become 1 into 2 will become 2 minus 2x minus 3 as it is, and in the same way derivative of 2x plus 1 is the constant term, derivative will be 0. Derivative of 2x will be 2, as derivative of x is 1. So 1 into 2 will become 2. Now we simplify this thing. 2 will be common from both these two terms. So we have left 2x plus 1 minus 2x minus 3. So this will become 2x plus 1 minus 2x and minus minus plus 3. 2x will be cancelled out. So we have 2 into 3 plus 1 will be 4. So the final answer will be 4 2s are 8 over 2x plus 1 whole square. Our next question is, we have to find derivative of x minus 5 into x minus 3. Let f of x is equal to x minus 5 into 3 minus x. Applying derivative on both sides, f prime of x is equal to d by dx of x minus 5 into 3 minus x. Here we are using our product theorem. X minus 5 into 3 minus x, this is in the form of fx into g of x. So our product theorem was f of x will be as it is, derivative will apply on g of x, plus g of x as it is, and derivative will apply on f of x, which is x minus 5. So x minus 5 will be as it is. Applying derivative on 3 minus x, that will be derivative of 3 will be 0 and derivative of x will be 1. This minus will be as it is. So we have minus 1 as a derivative of this 3 minus x, plus 3 minus x as it is, and derivative will apply on x minus 5. 5 is the constant term, derivative will become 0. We have derivative of x, which is 1. So we simplify this result. Minus into x minus 5 plus 1 into 3 minus x will be 3 minus x. So minus x plus 5 plus 3 minus x. Minus x will be minus 2x, and 5 plus 3 will be 8. So this is actually the final answer of the given question. Now we solve this question in another way. So let f of x is equal to x minus 5 into 3 minus x. Before we apply derivative on this question, we simplified this question. Let f of x is equal to x into 3, 3x, x into minus x, minus x square. Minus 5 into 3 will be minus 15, and minus 5 into minus x will be plus 5x. Now f of x is 5x plus 3x will be 8x minus x square minus 15. Now this is simplified version of the given question. As there is no more possibility to simplify this, so now we apply derivative. So differentiate with respect to x. So that will be f prime of x. When we apply derivative on right hand side, so derivative will apply by using some theorem. Derivative will be applied on 8x, then minus x square, and then minus 15. So that will be d by dx of x 8x minus d by dx of x square minus d by dx of 15. Here we use our theorem d by dx c into f of x. C will be as it is. So 8 will be as it is. Derivative of x is 1 minus derivative of x square by using power theorem, that will be 2x 2 minus 1 minus derivative of constant will be 0. So we have 8 minus 2x. The same result, but here we use technique before derivative. We simplified this question in this form. So you can see that if there is a possibility of simplification of the given question, then we applied simplification first and then we apply derivative. So that will be more easy. Rather we use our theorems, and either that will be product theorem or quotient theorem. So this is another technique to solve a question which is in the form of product. Our next question is differentiate square root of x minus 1 over square root of x whole square. Solution: let f of x is equal to square root of x minus 1 over square root of x whole square. So derivative will apply on both sides. Left side will be f prime of x and derivative will apply on this right hand side. But again we use our technique to simplify the question first before applying derivative. So rather we apply power rule here first. We simplified this question first. So this is in the form of a minus b whole square. So that will be a square plus b square minus 2ab. So that is square root of x whole square plus 1 over square root of x whole square minus 2 into square root of x into 1 over square root of x. Still we didn't apply differentiation here. Square root x whole square will be x. This will be 1 over x minus this, and square root x will be cancelled out. So we have x plus 1 over x minus 2. This can be written as d by dx of x plus this can be written as x raised to the power minus 1 minus 2. Now this is a simplified version of the given question. We apply derivative on this term. So by using our sum theorem, derivative will apply on each of these three terms separately. Derivative will be applied on x raised to the power minus 1 and on minus 2. Derivative of x will be 1. Derivative of x raised to the power minus 1 will be minus 1 x raised to the power minus 1 minus derivative of 2 will be 0. So here we have 1 as it is. This plus minus will be minus x raised to the power minus 2, and as this is in the form of negative power, we can make it positive by shifting it to denominator. So that will be 1 minus 1 over x square. After taking LCM, that will be x square minus 1 whole divided by x square, which is actually the derivative of our given question. So this is our next question. We have to differentiate 1 plus square root of x into x minus x raised to the power 3 by 2 whole divided by square root of x. solution, let f of x is equal to, same question, 1 plus square root of x into x minus x raised to the power 3 by 2 whole divided by square root of x. Again we are using our simplification technique before apply derivative. As you can see, if we apply derivative on this part, then this is in the form of quotient theorem. Here we have this numerator as an f of x and this denominator as g of x. So if we apply quotient theorem here before applying simplification, then that will be whole square of square root of x whole square, and derivative will apply on this numerator, and this numerator is already in the form of product of two terms, so that will be more complicated if we apply a derivative of this part which is actually of product of two terms, then minus this f of x which is in the form of product of two terms, and applying derivative of numerator which is square root of x. So this will become more complicated. So rather we apply derivative in the form of quotient theorem, we apply simplification technique to this part. So our simplification is this 1 plus square root of x will be as it is, and here we can take x as a common factor, so that will be 1 minus x raised to the power 1 by 2. This square root will be as it is. We can write it as 1 plus square root of x, x into 1 minus square root of x. And as this is x, this one is also x, so by using our simple algebraic technique, when we have same base, we can combine the power of these two terms. So here we have power 1, here we have power 1 by 2. So by using simplification technique, this x and this square root of x will be square root of x, and this 1 plus square root of x into 1 minus square root of x will be as it is. Now we apply simplification technique on these two terms. This is in the form of a plus b into a minus b. So we have a square minus b square. So when we apply simplification technique on this portion, that will be actually 1 square minus square root of x whole square. So here we have only this square root of x will be as it is, and by using this formula of a plus b and a minus b will be a square, which is 1 minus square root of x whole square, that will be 1 minus x. So we have here 1 minus x, and we can write it as square root of x, x raised to the power 1 by 2 into 1 minus x. By multiplying x raised to the power 1 by 2 to 1 will be x1 by 2 minus x1 by 2 into x. Again we use our algebra, that will be 1, and here we have 1 by 2, the power will become 3 by 2. Now we have the most simplified version of the given question. So we apply derivative here, left side will be f prime of x, and derivative will apply on right hand side will be x raised to the power 1 by 2 minus x raised to the power 3 by 2. Derivative will apply on separately both of these two terms. So x raised to the power 1 by 2 minus d by dx into x raised to the power 3 by 2. By using our power theorem, this 1 by 2 into x raised to the power 1 by 2 minus 1 minus 3 by 2 x raised to the power 3 by 2 minus 1. So we have derivative f prime of x is equal to 1 by 2 x raised to the power minus 1 by 2 minus 3 by 2 x raised to the power 1 by 2. This can be written as 1 by 2, this x raised to the power minus 1 by 2 will become positive 1 by 2 when we shift it into denominator, and we can write it as square root of x minus 3 by 2, this x 1 by 2 will be square root of x. So applying LCM on these two terms, 2 under root x is an LCM. So here we have 1 minus 2 will be cancelled out. So square root of x into square root of x will be x. This 3 will be as it is. So this is our required differentiation of the given question. Our next question is x square plus 1 whole square divided by x square minus 1. So let f of x is equal to x square plus 1 whole square whole divided by x square minus 1. Again, this one is in the form of quotient theorem. We have f of x divided by g of x. We applying derivative on both sides. So left side will be f prime of x and right side by applying derivative on this portion. So we use quotient theorem here. This denominator will become a square x square minus 1 whole square, and derivative will apply on x square plus 1 whole square, and this g of x, which is actually a denominator function, will be as it is minus. Now f of x will be as it is, which is actually x square plus 1 whole square. D by dx will apply on x square minus 1. When we apply derivative on this portion, this will be by using our power theorem. This 2 function x square plus 1 power 2 minus 1, and when we apply derivative on this portion, which is x square plus 1, and that will become 2x, and this x square minus 1 will be as it is minus this x square plus 1 whole square as it is, and derivative will apply on x square minus 1, which is 2x, and derivative of 1 will become 0. By applying derivative on this part, as we discussed earlier, this is actually in the form of f of x whole square. When we apply derivative of this part, so that is actually 2 f of x 2 minus 1, and then derivative will apply on f of x. We have already explained this rule or this theorem. This is actually generalized power theorem. So this 2 will be n actually x square plus 1 n minus 1, and then derivative will apply on this inner portion, which is x square plus 1, and when we apply derivative on x square plus 1 will become 2x, and the next we have already explained. So here we have 2x into x square plus 1 as a common factor. Then there will be left 2 into x square minus 1. This 2 and this x square plus 1 and this x as a common factor of these two terms. So we have only this 2 and this x square minus 1 minus, and from here this 2x as a common factor and the x square plus 1 whole square. We have taken x square plus 1 as a common factor, so we have only x square plus 1 raised to the power 1. So after simplification, left side is actually f prime of x. 2x into x square plus 1 was common factor, and the inner portion will be 2x square minus 2 minus x square minus 1. So again this thing will be as it is, and 2x square minus x square will be x square. This minus 2 minus 1 will be minus 3, and the denominator again will be as it is. So this one is actually our required derivative of the given question. The final thing we just want to explain why we not applying a simplification technique here. As if we apply derivative applying simplification here, that will be x4 plus 2x square plus 1 whole divided by x square minus 1. So we can see there is no any simplification by applying a square formula on f of x. So there will be no next simplification. So rather we go to simplification technique. We just apply our quotient theorem. So we can conclude, if there is no possibility of any simplification like in this part, then we will go towards derivative like this, and if there is a possibility of simplification as we discussed in the previous question, then we will move towards simplification and then applying derivative. So this one is our question 8.